Hello, this is Jennifer Dassinger with A Plus College Ready, and we are now in our third component of writing and naming compounds. Today, we will be looking at how to name bases and basic organic compounds. We'll start with our bases. Remember our definition of acid? Well, for every acid, there's probably something that has to neutralize it, and that is a base. We'll learn our definitions of acids and bases more in depth in a later unit. But for right now, our basic definition, no pun intended, is that bases are like our ionic compounds. And you have the name of the cation and the name of the anion. In this case, the anion that makes a base, and we're going to focus on our strong bases, are hydroxide. If you notice in the chart that I've provided for you, the table 1, we have some list of common bases. Notice we have sodium hydroxide. So again, we take the name, just like we did in ionic compound naming, we take the name of the cation and combine it with the name of the anion. In this term, it's a hydroxide. Now, if you notice, we do the drop and swap when we have different charges. So therefore, calcium hydroxide, the positive oxidation state of 2 for the calcium, will require 2 hydroxide units to bond to it. Therefore, the 2 is represented outside the parentheses of our polyatomic ion of hydroxide. It's a distributive property, remember. Last but not least, I included a weak acid because we use it quite a bit in terms of cleaning windows, and that is ammonia. And ammonia is NH3. It is a base. It's a weak base. And then we have ions of ammonium hydroxide, which is very common, and we use that compound as well with our ammonia. So I just want to give you an example of a non-hydroxide base, if you will. All right, moving on. There are some other organic bases out there, and they're pretty much amines. And an amine is a NH3 or NH2 structural unit that is attached. So I've given you some common amine bases, organic bases that we use every day. For example, serotonin. That's in our body. It's an important neurotransmitter that makes us all feel very happy. And one of my complete favorites is right next to it, caffeine, which I have to have every morning to survive on. Then there are a few other examples just to kind of give you an idea of where you're going to be headed after you take your freshman chemistry class in college. You'll be taking organic chemistry. Now, we're moving on into writing and naming our basic organic compounds. And there are 3 categories: alkanes, alkenes, and alkynes. Notice the suffix changes. Our first category is alkane, and it is a saturated hydrocarbon from a homologous series of compounds. Now, if you remember back from our biology day, when you were taking that course, you probably saw some of these. So let's go into it. If you notice, I have provided for you a general formula, and this general formula is fabulous because math never lies. CnH2n plus 2. Remember, the N is the number of moles of our subscript of our atoms bonded to each other. So if you notice in the chart, the 1, 2 through, and it does go to 10, I just stopped it at 8. If you notice, 1, 2, and 3, 4 are different prefix names than our molecular compounds. So remember, in our molecular compounds, we had mono, di, tri, tetra, right? Well, now in our basic organic compound naming, our prefixes have changed. One carbon is the prefix meth, 2 carbons are eth, 3 carbons are pro, 4 carbons are bute. So again, pentane all the way down to our 10, it stays the same. Now notice our suffix, the ane, what that suffix represents, and if you notice in the student notes and in our table here, is that it is a singly bonded carbon. So methane has 4 carbons around it, and you can plug into your equation the 1 For your carbon, the 2 times 1 is 2 plus 2, and that's going to give you the 4 hydrogens with it. So as you go down, there is a pattern. Notice ethane. If you notice ethane is C2H6. Again, use that general formula. I strongly recommend that you remember this general formula because it's going to help you not just with your alkanes, but your alkenes and your alkynes. All right, let's move to our next category of organic compounds, and this is our alkenes. Now, these are unsaturated hydrocarbons, and usually there's 2 categories of them, cyclic or acyclic, which simply means single, in a long straight chain. And these contain double bonds. So think about that. Our alkanes are singly bonded, and if you notice in the chart in the diagram, you'll be able to represent and see that the alkenes, notice the suffix changed to represent our double bond. The prefixes stay the same. Now notice our general formula has changed a little bit too. In other words, our general formula is CnH2n. So notice there is not a +2 after it. Remember, I told you that if you remember that alkane general formula, notice alkenes, well, just drop 2 hydrogens off, and now you have your alkene writing system. Or you can use this formula as provided. Obviously, a group of hydrogens must drop off to allow that double bond to occur between the 2 carbons there in that one bonding site. Remember, back to bonding, we did look at our single, double, and triple bonds. So this is ethene or ethylene that some of you are probably familiar with. Propylene or propene is C3H6, and then butene. And butene is C4H8. Again, notice the pattern. As the prefix increases by 1, the hydrogens double by 2. So you can also look at that pattern as well. Hexene, this is a common, it can be a straight chain or in a cycloform. I just want to give you an example to see what a cyclic acid organic compound alkene would be. Last category is our writing and naming organic alkyne compounds. These are also unsaturated hydrocarbons. Remember back from your biology days. So when we talk about saturated and unsaturated, our saturated organic compounds are singly bonded. And our unsaturated compounds that we talked about, or molecules that we talked about in biology, are either going to be a double bond or now a triple bond. So if you notice the suffix has changed again, a YNE ending, and it is pronounced alkyne. Again, 2 categories, cyclic or acyclic. And in this case, I've already shown you a cyclic one in terms of our double bond, so I didn't feel necessary to show it again. These are carbon-to-carbon bonds that contain triple bonds. Notice the general formula, CnH2n minus 2. So ethylene, if you go back in your student notes or go back to your previous slide, as you go from ethane, our ethane was C2H6. Then if you remember your ethene is C2H4. Well, now your ethine, acetylene essentially, is C2H2. Then you have your propene, which is C3H4. Again, patterns. Always watch your patterns. Our last category that I wanted to add is our hydrate naming. And hydrate is a substance that contains loosely bonded amounts of water to it. And especially here in the South, we have to really watch our ionic compounds because they will absorb the moisture in the air, typically in vapor form, and that amount of water will attach to that ionic compound. Each ionic compound has a certain ratio of water that it can absorb and becomes to the point of saturation. The prime example that is most used in most of your labs is copper 2 sulfate, pentahydrate. Again, look at the ionic naming. The copper, Roman numeral 2 from its stock naming, sulfate. And then notice the dot. Now, this is where math and science differentiate a little bit. That dot means to add, not to multiply. The dot means to add, not to multiply. The N, of course, is your number of moles of water loosely bonded to that salt. And again, your prefixes. So the prefixes go back to mono, di, tri, tetra, pent, etc. So it's different from the organic naming, and it goes back to that molecular compound prefixes. A little confusing, I know, but think organic is different from the rest. And if you notice over to the far right, the hydrate, once water is removed, is called an anhydrous form. So that white powder over to the far right is still copper 2 sulfate, but without the 5 waters. So ideally, you'll do a lab called empirical formula of a hydrate, and you're going to try to remove the water as much as possible through a series of testing experimentally and lab to remove the water. And notice in the middle of the screen, you see when as soon as water is added, you're going to have that nice color change back to its copper 2 sulfate pentahydrate state. Hope this was educational and informative, and good luck with naming.